Hello embedded system lovers, have you experienced an LED glitch or LED flicker before, or a chaotic serial monitor display? Imagine this: you connect a button to your Arduino or ESP32, but when you press the button, sometimes it works, sometimes it doesn't. That's because the input pin is floating. It doesn't know if it's high or low. To fix this, we will use a concept of pull up and pull down resistor to give a default or known. So guys, here is a proto simulation of the pull up resistor. Alright, so one terminal of the push button is connected to the ground. The other terminal is connected to one terminal that is connected through a resistor, pulling it high to a VCC 3.3 volts or 5 volts, and then the other terminal to the logic probe that we're using to represent the pin that will be going to the microcontroller. Alright, so a pull-up resistor connects the input to a high voltage, which is usually 3.3 volts or 5 volts. So when the button is not pressed in its default state, the logic probe, which is the pin going to our microcontroller, is seen high. So in its default state, when the button is not pressed, the logic probe, which is the pin going to our microcontroller, is seen high. So this is how the pull-up resistor works. So a pull-up resistor connects the input to a high voltage, usually 3.3 volts or 5 volts, through a resistor. So when the button is not pressed, the pin is high, but when it's pressed, it connects to the ground and it's read low. So it's that simple. So the pull-up resistor, the voltage when the button is idle, it's called pull-up. So it's high in its default state. When the button is idle, it's pull-up. It is high, but when it's pressed, it is low. Alright, so this is how the pull-up resistor works. Just remember, when the button is pressed, it is low, but when it's not pressed, it is high in its default state. So this is how the pull-up resistor works, and we can use this to resolve the issue of the chaotic serial monitor display or LED flicker or glitch. Now this is the pull-down resistor. The pull-down resistor is a direct opposite of the pull-up resistor, and what you are seeing here, which is also connected alongside the button. All right, I will start the simulation. You see the simulation and how it works. So you can see that one terminal of the button is connected to the VCC, which can be either 3.3 volts or 5 volts. It's connected to the button, and then the other terminal is connected to the terminal node to the logic probe that we're using to represent our pin that is going to the microcontroller, which can be either Arduino or ESP32, and then the other pin is connected through a resistor to the ground, which we are going to be considering as a pull down resistor. So the pull down resistor is a direct opposite of the pull up resistor. That is how it works. So you can see when I press the button, nothing is working. Now let me simulate, and then you see how it works. So now a pull down resistor does the opposite. It connects the pin to the ground through a resistor. That's how it works. So when the button is idle, the pin reads low. When the button is idle, the pin reads low. You know, for pull up resistor, when the button is idle, it was reading high. Alright, but when you press the button, which is this push button now, when we press the push button, that's when we begin the simulation. We press the push button, it connects to VCC. Alright, you can see now the button is idle, so it's still saying 0 even when we began the simulation. But when we press the button, it connects to VCC and the pin reads high. You'll see that now. Once we press this button, the pin reads high. That's the pin going to our microcontroller. It reads high. So pull up by default is high, but pull down by default is low. So by default, without pressing the button, it is low. Now we will now see what happens when we now press the button. Remember, what we are going to be looking at is our logic probe. You can see the button is high when we press the button. So as we press the button, it becomes high. It's high. Why? Because it connects to VCC. You can see. So there is now a closed circuit, a closed path for current to flow. So it connects, and then the pin reads high. So this is a direct opposite of the pull down resistor. So both concepts, both circuits can be used to resolve the issue of LED flicker, or the issue of LED glitch, or the issue of the chaotic serial monitor display we saw earlier. which is the concept of the pull-up resistor and pull-down resistor. So we're going to be seeing here is the circuit I built without a pull-up or pull-down resistor, and see what happens when I press the button. This issue can be corrected by adding an external resistor for a pull-down resistor, or writing a software program like this to correct that issue of the LED flicker or our circuit not working properly well because a pull-up or pull-down resistor was not connected. So you can write a software program that can correct that issue. So this software code is to use an inbuilt function here in Arduino to automatically connect an internal resistor, all right, of about 20k to 50k between the pin and the positive voltage in the Arduino, all right, which is high, of course, just as we discussed earlier, pull-up resistor. So you can use a software program like this to automatically connect an internal resistor as a pull-up resistor so that your circuit can work properly well. All right, so the other alternative is to connect an external resistor of maybe 10k ohms, or maybe like this 20k ohms, so as to also get the same effect, but this time as a pull down resistor, all right, for a circuit to work properly well so that your LED will not be behaving erratically. All right, so with this, using a program like this, you can correct or create the pull-up resistor effect, or connecting an external resistor to also create the pull-up or pull-down resistor effect. Now let's see the output of this program on our circuit. It's working perfectly well. It's turning on the LED. Here is the Arduino code for the hardware pull-up resistor setup that is different from the previous program where we got to use a built-in function, the input pull-up resistor. All right, but this time we're not going to be using that inbuilt function pull-up, so we're just going to declare our button as an input and also declare our LED as an output, and then we now connect an external resistor of 10k ohms and work with external resistor as pull-up. So here is the circuit after connecting the resistor. It's working perfectly well. All right, so this is the end of the video, and please like, share, subscribe to my channel if you are new to this channel. If you find this video very valuable and insightful, please click on that like button, like this video, and subscribe to my channel so that this video can be recommended for other embedded system developers. All right, so to be a solid embedded system developer, tricks like this pull-up or pull-down resistor, all right, can make you a pro hardware designer. All right, these are some of the concepts you need to learn in order to strengthen your skill set as an embedded system lover or embedded system developer. And please again, subscribe to my channel if you are new to this channel, and like this video if you find this video very valuable and insightful. Please like, subscribe, so this video can be recommended to other developers alike, and it will help the YouTube algorithm and also encourage me. Thank you for watching, and bye bye.